I am Savitha and my topic is clustering, methods of clustering. There are many methods. Now I am explaining hierarchical clustering. What is clustering? Definition for the clustering. Let us see. Clustering is the task of grouping a set of objects in such a way that objects in the same group are more similar to each other than to those in other group. Clustering is an unsupervised machine learning method identifying and grouping similar data points in larger data set without concern for the specific outcome. It is used to classify data into structures that are more understood and manipulated. Hierarchical clustering involves creating clusters that have predefined ordering from top to bottom. For the example, all files and folders on the hard disk are organized in a hierarchy. This is the clustering structure. These points are represented set of object or set of data, and these points are represent grouped data or grouped object by its characteristics like colors and shapes. Likewise, there are two types of hierarchical clustering. One is divisive, second one is agglomerative. Let us see divisive clustering. In divisive clustering or top-down clustering approach, initially all the points in the data set belongs to one cluster and split is performed recursively as one moves down the hierarchy. Steps of divisive clustering. Initially all the data points in the data set belong to one single cluster. Partition the cluster into two least similar cluster. Proceed recursively to form a new cluster until the desired number of cluster is obtained. Let's say second one is agglomerative clustering. Agglomerative clustering is a bottom-up approach. Initially, each data point is a cluster of its own. Further pairs of cluster are merged as one moves up the hierarchy. Steps of agglomerative clustering. Initially, all the data points are a cluster of its own. Take two nearest cluster and join them to form one single cluster. Proceed recursively step 2 until you obtain the desired number of cluster. The following three methods differ in how the distance between each cluster is measured. First one, single linkage, complete linkage, and third one, average linkage. First one, single linkage. In single linkage hierarchical clustering, the distance between two clusters is defined as the shortest distance between 2 points in each cluster. It is based on grouping cluster in bottom-up approach. At each step, combining two clusters that contain the closest pair of elements not yet belonging to the same cluster as each other. This is the example for single linkage. For example, the distance between cluster R and S to the left is equal to the length of the arrow between the two closest points. And this is the equation for the single linkage. L of R comma S is equals to minimum distance of X Ri comma X Sj. A graphical representation of the single linkage. Single linkage hierarchical clustering treats each data point as a singleton cluster and then successively merges cluster until all points have been merged into a single remaining cluster. Then we merge in each step these two clusters whose two closest member have the smallest like this smallest minimum pairwise distance. Time complexity of single linkage is theta of n square. Second one is complete linkage. In complete linkage hierarchical clustering, the distance between two clusters is defined as the longest distance between 2 points in each cluster. The clusters are then sequentially combined into larger cluster until all elements end up being in same cluster. The method is also known as furthest neighbor clustering. Example for complete linkage. We merge in each step the two cluster whose merges has the smallest distance, or the two cluster with the smallest maximum pairwise distance. According to time complexity, the worst case for the complete linkage is theta of n square log n. And this is also example for the complete linkage. For example, the distance between the cluster R and S to the left is equal to the length of the arrow between these two furthest points. L of R comma S is equals to maximum distance of I comma J. I belongs to R and J belongs to S. And third one, average linkage. In average linkage hierarchical clustering, the distance between two clusters is defined as the average distance between each points in one cluster to every points in other cluster. This is the example for the average linkage. For example, the distance between cluster R and S to the left is equal to the average length each arrow between connecting the points of one cluster to the other. Average linkage clustering merges in each iteration the pace of cluster with the highest cohesion. For each cluster, we also updated sorted list of merged candidates by deleting the two just merged cluster and inserting its cohesion with the just created cluster. Each iteration thus takes theta of n log n. Overall, the time complexity for average linkage is theta n square log n. That's all. Thank you. Thank you for everyone.